Welcome to the channel, guys. Our title is Drift Avoidance in Photovoltaic System using Modified Perturb and Observe MPPT algorithm. Our project is done by S. Shivahari, Justice Muthurapan. Our project is guided by Dr. K. Karnanidhi, Associate Professor, Tubi Department. Let's look upon the abstract of our project. This project presents the modified Perturb and Observe MPPT algorithm, and this algorithm is one of the most tracking techniques. This proposed system is used to avoid the drift problem in the PV system by combining the information of change in current and an addition to change in power and change in voltage. The proposed algorithm accurately tracks the maximum power and avoids drift in fast changing weather conditions. Next, let's look upon the aim of our project. Our aim of the project is to improve the efficiency of the system compared to the existing system. It is used to reduce the power loss and gaining extra power from the PV panel. Now let's discuss about the existing system, which is presently used in the PV module. The perturb and observe method is also known as perturbation method. Is a type of MPPT algorithm. This algorithm is used to modify the voltage or current of the photovoltaic panel until you obtain the maximum power from it. Main problem in this algorithm, the sudden change in atmospheric condition causes the PO algorithm to drift away from the MPP. That is maximum power point. This graph is a representation between power and voltage. This is the steady state 3-level operation of PO algorithm. The 1 to 3 are the 3 operating points of the PV module. Now let's discuss about the proposed system. That is our project. The modified PO MPPT algorithm is simple and efficient tracking technique to track the peak power. In order to the proposed system, it is used to avoid the drift problem in the photovoltaic system. The existing system is suffering from drift in case of increasing insolation, and the drift effect is severe in case of rapid increase in insolation. This slide represents the literature survey. This survey we discuss about different researches done upon the PV model using different types of MPPT algorithm. Some examples are hill climbing, uh, MPPT control, and perturb and observe, and particle swarm optimization MPPT algorithm. Now let's discuss about the block diagram of our project. Initially, the PV module is the main component of our project, which is directly connected to the SEPIC converter. This type of converter, which is used for converting DC to DC converter, it is also used as buck boost converter. And below that converter, we connect the controller, which is the modified Perturb and Observe MPPT controller. This is the main component of our project. This modified MPPT controller is used to track the maximum peak power point from the voltage and current, irrespective to get the maximum power from the PV module. So the Perturb and Observe application is that to avoid the drift values of the voltage and current. So finally, the load is connected directly to the SEPIC converter. The next is the flowchart of the modified PO algorithm. This represents the logical diagram of the working of the controller we use in our project. So here we can see initially we read the voltage and current values from the panel and calculate the power from it by multiplying the voltage into current and initializing the value in power variable. Then we consider different types of conditions to get the output from the maximum and drift free output from the output PV module. Next we can see the circuit diagram of our project. Initially the PV module is taken and the circuit is directly connected to the different components like it is connected to the SEPIC converter, which consists of different components like the inductor, capacitor, MOSFET, and diode. So all these components joins to form the SEPIC converter, which is finally connected to the load RL.